Okay, so we're going to start this lesson by looking at fractions and specifically at multiplying fractions. So if we've got P, Q, R, and S, and they are real numbers, and Q and S are not equal to 0, of course that's important because we can't have 0 in the denominator, then when you multiply these, you simply multiply straight across, and you have PR divided by QS. If we look at the same thing here, we've got PR divided by QR, we have that equal to PQ. And just a reminder, because that's the same as P over Q times R over R, and R over R is 1. This will become very important when we start talking about rational expressions. We'll also look here at laws of exponents, things that you've already seen, right? Two powers with the same base, you add the exponents. If you're multiplying two factors and raising that product to a power, it's each factor to that power. And if you have a power raised to another power, you multiply your two exponents. This is not new. Here is the new information. If you are dividing, so you have a to the m divided by a to the n, so the same base, you just take a to the m minus n. Now that is provided that m is the larger value. If the larger value is n, you simply take the reciprocal of this. So it's 1 over a to the n minus m. When we're looking at quotients of monomials, we will consider it to be simplified when the integers, the coefficient integers, are relatively prime. What that means is that you can't factor anything out. Doesn't mean that it has to be a prime number. It just can't, you can't have something that can be factored out. Each base appears only once, so you can't have y squared times y cubed over y to the fifth. And you're not allowed to have any powers of powers, so those all have to be simplified through. Like many things, this is easier to see. So if we take a look at this first one, the way I like to approach these problems is I have 9 divided by 3 times x cubed over x squared times y squared over y to the fifth. And I simplify each one of them separately. 9 divided by 3 is 3. X cubed minus x squared would be x to the 3 minus 2. So that would just be x to the first power, which we simply write as x. And then y squared over y to the fifth is 1 over y to the 5 minus 2. So that would be 1 over y cubed. And from here we do simplify this further so that it becomes 3x over y cubed. Taking a look at the next one, we have 4 over 18. We have a cubed over a, and we have b over b to the fourth. 4 over 18 isn't going to simplify to something nice, but we do know we can simplify this to 2/9. A cubed over a would be a to the 3 minus 1, that's a squared. And then b over b to the fourth would be 1 over b to the 4 minus 1. So that's 1 over b cubed. And then we simplify. This becomes 2a squared over 9b cubed. And the third one, what I would do is multiply first and then divide. So this becomes 3c to the fourth, d to the fifth. And the thing you have to multiply would be the 2 and the 6. That becomes 12. C squared, d squared. If you notice, I rearranged the d squared and the c squared because multiplication is commutative. So now, 3 over 12, c to the 4th divided by c squared would be c squared. D to the 5th divided by d squared would be d cubed. So we have 3c squared d cubed over 12, which that means I didn't simplify that. This becomes 1, that becomes 4. So let's try that again. C squared d cubed over 4 is your final answer. Now we've got some powers of powers, and what you need to understand is that the same rules do apply. So this becomes 3 squared r squared over 5 squared s cubed squared. 3 squared is 9, r squared, 5 squared is 25, and s cubed squared is s to the 6th power. Now, I can't factor anything out of 9 and 25. I can't do anything with r squared and s to the 6th, so this is actually my final answer. Taking a look at the next one. I have y to the 4th cubed, that's y to the 12th. I have 2 cubed, that's 8. And I have x squared cubed, that would be x to the 6th. So this becomes 4x y to the 12th divided by 24 x to the 6th y to the 7th. 4 over 24, that's 1/6. X divided by x to the 6th would be 1 over x to the 5th power. And then y to the 12th divided by y to the 7th would be y to the 5th power. So we simplify that as y to the 5th over 6x to the 5th. Last one. -2 squared would be 4. U cubed squared would be u to the 6th. V squared squared would be v to the 4th over 12 u squared v to the 4th. 4 divided by 12 is 1/3. U to the 6th divided by u squared would be u to the 4th. And v to the 4th divided by v to the 4th is v to the 0 power. Which gives us u to the 4th over 3. V to the 0 power is the same as v to the 4th over v to the 4th, and anything over itself is 1. So to piggyback on that last problem we did, we're looking here at these rules. So if we have a to the m times a to the n, we add our exponents. But if n is equal to 0, what that means is we have a to the m times a to the 0, which is just a to the m. So we're looking at what are we doing here? We can divide both sides of the equation by a to the m, and we discover that a to the 0 is equal to 1. If n is a negative integer, and we multiply a to the negative n times a to the n, we end up with a to the 0, which is 1. This is an identity. So what it shows us is that a to the negative n is a reciprocal of a to the n, which is why we end up with this rule. So you don't have to write these down. They're already in your notes, but highlight them, put gigantic stars next to them, do what you need to do. Anything to the 0 power is equal to 1. Anything to a negative power, you do 1 over the positive power. So we will start with expressing in simplest form with no negative exponents. So we have 458 times 10 to the negative 4th, so that's 1 over 10 to the 4th power. That means a 1 with 4 zeros. And that ends up being 0.0458. This is called scientific notation. We will not spend time in this class on scientific notation, but you will see it a lot in your science classes. Okay, taking a look at the next one. These get quite a bit more complicated, although the same rules will apply. 6 to the negative 1 means that 6 goes in the denominator. X to the negative 2 means that x squared goes in the denominator. Z cubed means that z stays in the numerator. 5 to the 0 means that that's just 1. Z to the negative 2 means that z squared goes in the numerator. So anytime you see a negative exponent, you move it to the other part of the fraction. So here we've got negative exponents that all had to move up, which means that I missed one. I missed x to the negative 1. Becomes x to the first. So I have here x, z to the 5th, over 6x squared. Now when we start canceling, you'll see this happen a lot. I will cross out this x, and I will cross out this 2. So that will tell me that this is now z to the 5th in the numerator and 6x in the denominator. Trying another one. 4m to the negative 2 over n. That becomes 4 over m squared n. Then, with this next one, because I'm raising this whole fraction to the negative 1 power, I can actually just take the reciprocal. 3n squared over m cubed. So that's not 4. That will be 4 times 3, which is 12. 12n squared over m to the 5th power, and I got that by multiplying m squared times m cubed times n. So if I look in the numerator and denominator, there's an m in the denominator but not the numerator. There's n squared here, n here. So this will cancel, and I will get 12n over m to the 5th power. With this, we're actually going backwards. We're going to express this without using fractions. So the first one would be 3 times 1 over 100,000. So that becomes 3 times 1 over 10 to the 5th power. I know it's the 5th power because there are 5 zeros. And because I can't use fractions, 3 times 10 to the negative 5th. Next one, 2a. Now in the denominator, I've got t to the negative 3, b to the negative 1. On this last one, the first thing that I will do is simplify. Then I will remove all the fractions. So if I have 8x squared y over xy cubed, This will become x to the first. That will become y squared. And I have the numerator is 8x. The denominator is y squared. So I will have 8x y to the negative 2 power.